Good morning. Good morning. Thank you very much for being here. Thank you. It's very nice to see so many people this morning. I was not expecting to have the room so full for a lightning talk in the morning, so it's great. It's a success already. Just a quick announcement before we get to move on the lightning talks. So, as I hope you all know, we will do this lightning talks discussion now, and then we'll move on to the next room where you will have your poster that will be loaded and preloaded. So if you do not know your board number, you will have to go around to find it. If you have received the email that I sent on the Sunday and you looked at your board number, then you will see there's a number next to the screens, and it will be easy to find. But it's not so many screens. I'm sure you will be fine. What I will ask all the speakers for the lightning talk is the great conference team here on the left will help us with the order. We will go in the order of what was in the schedule, and they will help you to find when you're talking and so on. So if all the speakers from the first hours, if you could go see my colleague on the left side, that would be excellent. And then what we ask you is to be mindful of the time so that we can go through in 1 hour. And so get one minute for each of you that is scheduled. And our colleague will show your slide behind, and you can see your slide on the screen here. So if there's any question at the end, I will be around here and we will be able to discuss and address questions. And I think we can start with the first one. Thank you.
So, ladies and gentlemen, I have the pleasure to present the first talk, and I will be talking about modeling low-frequency acoustical propagation in shallow water wedge. There is a well-known thing that underwater sound of very low frequencies may propagate over several tens of kilometers. And I would like to now, on the basis of the geoacoustic model, like a 3D benchmark model of the fluid wedge with the elastic bottom, which is shown here for this configuration with the point source in the water and the receiver on the sloping bottom, to explain this phenomenon. And I will explain it using the theoretical approach. It's a method of generalized ray. In my poster, in 1 hour, you can learn about this, and then I show you that the theoretical model predicts that the recorded pressure is composed of 3 waveforms: the source signal, multi-regular reflected waves, critical waves, which they should come, and the shorter waves. So there are 3 waveforms. The model also accounts for the attenuation, and the results are shown here for 2 pulses. On the left-hand side, this is the pulse with a center frequency of only 3 Hertz. And on the right-hand side, this is the pulse with the center frequency of 33 Hertz. Yes, 36 Hertz. And you see these 3 waveforms: refracted, 61 dB, regularly reflected, 51. It's finished. Yes. And then, yes, thank you. Sorry. You should say. Yes.
So, good morning. I will not go to physics. It's more about tsunami. I would be happy to receive you if you are interested to know a little bit about tsunami deposits, about history. For the first time, we could spot some tsunami deposits in one of the most important cities in Eastern Mediterranean, Alexandria, in a very spectacular location near to the Royal Quarter. If you are interested to know about what happened to the city in the 4th century, I will be happy to receive you at panel 2. Thank you.
So good morning, everybody. My name is Ingo Grevemeyer. I'm a marine seismologist, and what I will do here is I will use seismic stations out of the Mediterranean, which we deploy to look for earthquakes to characterize the ambient noise level in the Mediterranean Sea. However, so we don't know precisely what the basic background level is, and therefore I use stations from the CTBTO all over the ocean basins to make a kind of characterized background reference model. And I will show you in my presentation today, so how noise levels are differently between different basins and like a gateway to the Mediterranean Sea. Thank you very much.
Hi, I'm Siobhan Nicholson. With the climate in the Arctic changing faster than anywhere else on Earth, we can no longer rely on past or even current observations to predict ocean acoustic propagation or the ocean acoustic environment going forward. So global Earth system models are a way to investigate changes to geophysical systems under future climates. Here we're looking at the US Department of Energy's Energy Exascale Earth System Model to see how well it estimates parameters controlling Arctic Ocean acoustic propagation. We compare sound speed profiles and acoustic travel times in the middle based on the model output with measured quantities in the Canada Basin. And we discuss how the results compare, long-term trends, and implications for understanding Arctic Ocean acoustic propagation going into the future. Okay. I have another one. I have one more. The next slide is also mine. Oh, is there? Okay, great, thank you. Okay, switching gears to seismic noise on the seafloor. High ambient noise levels on the seafloor have been a barrier to using seafloor seismic stations to complement land-based networks for monitoring. The seafloor moves in response to a range of environmental forcings at different frequencies. So here we focus on the frequency band around 1 hertz, which is important for detection of seismic body waves. So at this frequency level, the dominant noise source is ocean waves overhead. And so we find that in addition to the strength of the local wave field, the response of seismic instruments on the seafloor varies by site. In this study, in an effort to determine the major site factors controlling response and to help identify promising seafloor sites for seismic monitoring, we begin to map out the patterns of seismic response to sea surface waves across the global ocean.
Thanks for coming out early in the morning with the social event last night. That's not my talk. Did I jump on? Sorry, I spent all day thinking I followed Steve.
Thank you very much. Hello, everybody. My name is Juan Domingo Gonzalez, and I'm going to present my e-poster. Well, it's about the boundary element method. The boundary element method can solve propagation problems in 3D homogeneous media, but it is expensive in computational resources when long ranges are desired. To cut down on the computational cost, a matching scheme is considered. The propagation problem is solved in successive range steps. The complete theoretical formulations and a first numerical test are presented, and results are encouraging, although certain errors demand further research. Oh, okay, thank you very much.
Hello, my name is Dirk Metz. Last year, our colleagues from the IDC came across a bunch of rather oddly shaped signals that stem from a region that is known as the South Sandwich Arc in the Southern Atlantic Ocean. We believe that the sequence of arrivals that you see here stem from a submarine volcanic eruption there. And if that holds up, it would be the first observation of a submarine volcanic eruption in that region in more than 50 years. Thank you.
Let's try this again. So my name is Kevin Heaney, and I'm pleased to present a talk with a bunch of colleagues from CTBTO. We're doing improvements to hydroacoustic processing utilizing 3D ocean acoustic propagation. So for 50 to 20 hertz sound, which the seismologists think of as very high frequency, and the underwater acoustics people think of as low frequency, the ocean is shallow, and if it's shallow, then waves diffract and refract and bounce and propagate three-dimensionally. And so we've been working on three-dimensional acoustic models to integrate with the IDC processing system. So the plot on the bottom left is the coverage of the Diego Garcia South site, and you can see that sound bends around continents and shelves and islands. And the plot on the bottom right is the travel time tables, also computed using 3D parabolic equations. So thank you.
So, good morning, everybody. We are going to present some of our works which we have performed by looking at infrasound from wind turbines. Well, renewable energy, of course, is quite lovely. However, it might introduce some problems in detection capability to infrasound stations. And we carried out some field campaigns and trying from this data to provide some recommendations for minimum distances between an IMS infrasound array and the erection of wind turbines in the vicinity. And if you want to learn more of what we have done and what we have achieved, come and visit our poster. Thanks.
Good morning, everybody. I am not Ronan Lebras. I am talking on his behalf. We spent some time analyzing signals originating from Hunga Tonga volcano eruption. Ronan has come across an interesting publication which described signals which originated from another large volcanic eruption, Krakatau. So it was interesting to compare travel times, which we recorded at the IMS and non-IMS stations, and stations which were in the network when Krakatau erupted. If you want to have some insight into the study, please come and see poster 18. Thank you so much. I can continue, but I haven't.
No, it's not mine. Yes, it's mine. Sorry, I don't have this slide, but good morning, everybody. I'm Giacomo Belli from the University of Florence, and today I'll present a study, integrated analysis of small fireball events using recorded both with old sky cameras and an infrasonic array. And based on optical data, the events are characterized in terms of physical parameters and the trajectory. And then we analyze the infrasound signal with array processing technique and retracing to locate the source. And then we compare the infrasonic amplitude reconstructed at the source with the physical parameters of the meteoroid. And results show that we have a good agreement between the infrasonic reconstruction of the localization of the source and the optical trajectories, while we got no clear relation between the source parameters and the infrasonic amplitude, suggesting that more research is still needed. And if you want to see more, come to see my poster, and thank you.
I'm a geonist Kintner at Los Alamos. This is some extra work that I did looking at the earthquakes before and after the 2022 Tonga explosion there. And we did some high precision source characterization using the surface wave observations from there. You can see some of that work there in the figure. And it ends up telling a very interesting story. So I'm happy to discuss it. So thank you.
Good morning again. Now I am representing analysts, so it's our work. Normally, when we do routine analysis, we sometimes see T phases which were recorded at other than hydroacoustic network. We looked at 23 years of our bulletins to identify stations at seismic and infrasound network, which recorded hydroacoustic signals. And you can see in the map the ones which we identified. You can also see an example of a T phase which was recorded at an infrasound station. Not everybody would expect this to happen. So if you want to see more how this study can contribute to identifying hydroacoustic signals, also to maybe tune a bit our T phase stations, please come and see poster number 21. Thank you so much.
Good morning. My name is Yasmin Hamid Shamkhi from Iraqi National Data Center. In this study, we analyzed the eruptions of Tonga at Mauna Loa by using IMS data and IDC products. It is my pleasure to invite you to visit my e-poster during this day. Thank you very much.
Good morning, everyone. My name is Uche Madu, and I work with the Nigerian Atomic Energy Commission. In the course of the Tonga eruption, we examined the foreshock and the aftershocks. You can come and visit my poster, and we will deliberate on what we found. Thank you very much.
Good morning, ladies and gentlemen. My name is Thawatchai Iti Puntanakot. I'm working as the manager of the Thai NDC in Bangkok. Yeah, this study we try to find why the radioactivity of lead-212 in collect at the RN65 near Bangkok is very high compared to the neighboring station in Malaysia and Philippines. So, and we also know that the monsoon and the season have very high impact for the high level of PM 2.5 in Thailand in exact period of the year. So this study we try to bring, the data of the radioactivity of lead-212 and barium-7 report in RRR. To analyze with the monsoon and season data in Thailand, and we find some reason why the radioactivity of lead-212 in Thailand is very high. Thank you very much.
Hello, everybody. My name is Andrea Chong. I'm from the Lawrence Livermore National Laboratory, and today on my poster, I'll be talking about the seismic network expansion project in the Caucasus in Central Asia. So this is a multi-year project to expand national seismic networks in the region, and we are working with monitoring centers in 6 countries to improve regional seismic coverage and through equipment upgrades and modern installation practices. If you'd like to know more about the project, please come to my poster in about an hour. Thanks.
Good morning, everybody. I'm Duccio Geri. I am a PhD student of Florence University. The research that I will present is on monitoring volcano with the infrasound array of IMS network. In particular, I conduct an evaluation on 16 infrasonic IMS array in order to detect volcanic eruption, adapting a local infrasound early warning system to global observation, using infrasound data of the last decade. The notification provided by the algorithm are then compared with the bulletin reports of global volcanism program in order to obtain the reliability of the algorithm and the rate of false alerts. Results show that the algorithm is able to provide the reliable notification, considering also the low false alert rate. For further details, come to see my poster. Thank you.
Yes. Good morning, everyone. My name is Bernardo. I come from Madagascar, and this poster is about tsunami warning. What is the main objective? We did some simulation from the Sumatra event on 24th of April this year. We did some mapping, inundation and evacuation zone. So if you want to learn more about the station, please visit on our poster. Thank you.
Okay, I again. I'm still Giacomo from the University of Florence. And now it's not mine again, but okay. I'll present a study on the infrasonic analysis of the break-off event of an aging glacier at Mount Tiger in Switzerland. The collapse generated a broadband signal consisting of a higher frequency infrasonic signal followed by a lower frequency oscillation, dispersive one. And the high frequency component was analyzed with array processing techniques, and the results are used to estimate the velocity and the volume of the collapsing mass. And then the lower frequency component is modeled with a simple fluid dynamic problem. And this study highlights the potential of using infrasonic arrays to detect and characterize break-off events at glaciers. For further details, come to see my poster, and thank you again.
Good morning, everyone. My name is Jolanta Kuśmierczyk-Michulec, and on behalf of my co-authors, I would like to encourage you to see our poster where we share the knowledge, what is possible to do with IMS data and how to get access to IMS data. So it's about VDEC, which stands for Virtual Data Exploitation Center. In our poster, we also include short animations and provide a link to previous briefings related to SNT, where participants and users who have a VDEC account share their experience, what they did with the IMS data. So thank you, and I encourage you to see our poster. Hello again. I would like to encourage you as well to see another poster where this time we present a short study related to using IMS data for the purpose of study climate change that we observe at one of IMS stations that is in the region of Spitsbergen. So if you ask yourself whether environmental measurements from the IMS network of the CTBTO be used to evidence climate change. So we provide the answer. So please come and see the results presented on our poster. Thank you.
Thank you. Once again, my name is Madhu, and we carried a study on the interconnection between the CTBT and the MPT. The CTBT deals with ban of pests, while the MPT deals with prevention of the science. So we looked at the two treaties and we saw the interconnection between them, and we exposed it in our poster presentation. You can join us and then we discuss about it. Thank you very much.
Hello, I'm Dr. Mahfouza Parveen, Associate Professor, Department of Environmental Science and Disaster Management in Daffodil International University, Bangladesh. So here actually in my poster, I have presented that I want to use CTBT's data for the research purpose and for the in disaster management sector in Bangladesh. And also I want to involve my students like as youth involvement, to increase the youth involvement in CTBTO. So this is very like a beginner's poster presentation for Bangladesh. So please visit my poster presentation. Thank you.
Hello, good morning. My name is Pedro Paulino. I'm from Dominican Republic. I'm gonna have a poster about dating paleo tsunami with strontium. We, in our island, it is in the Caribbean. The island of Hispaniola is divided in two countries. We have support some kind of seismic activity during time. Last time was 1946. So we're trying with using strontium and RF, X-ray radiometric, to date drawouts and dates tsunami. So we will be able to have some kind of emergency plans, how in the time the climate has changed. I'll be on 62. If anybody or you is interested of it, I would love to talk more of it. Thank you very much. Have a nice day.
Thank you. Good morning. My name is Robin Yani. I am from Guatemala. We use the data from APG auxiliary station 37 to monitoring earthquakes. APG is located in the border of major tectonic plates, North American and Caribbean. In 2018, we detect two moderate earthquake, and throughout APG, do the high quality waveform, we detect another 33 earthquakes, and we estimate the distance, average distance and magnitude, and we estimate one sequence like main shock plus aftershock. APG currently is used by routinary monitoring earthquake in my country. Thank you.
Okay, until they find the right slide. Okay, they found it. I'm Shachar, I'm from the KNMI in the Netherlands, and I'm working on the seismic characterization of the next Einstein telescope site. If you're interested about the Einstein telescope or about vibrations in the subsurface at 300 meters depth from wind turbines, come by the poster and we can have a discussion about gravitational waves, about vibrations from wind turbines. Thank you. And that's it. So thank you very much for all the speakers. There is more posters to see because some of the authors did not share the lightning talks. So you will see there is more posters in the room next to you. The posters are already loaded on the screen, so you can already go and find your own poster and discuss with the authors. You're welcome to go already now. Thank you very much for being there.